Betelgeuse, a monstrous red supergiant star situated in the Orion constellation, is a fascinating celestial object that has captured the interest of astronomers and astrophysicists alike for quite some time. If it were positioned at the center of our solar system, its size would extend far beyond the orbit of Jupiter, dwarfing even the Sun. This giant star's immense presence is staggering, and its ongoing changes could lead to a catastrophic event on an unprecedented scale. Scientists, including renowned experts like Brian Cox, have expressed concerns about Betelgeuse, as it has been sending out unusual signals across space. These developments have raised a crucial question. Could we be on the verge of witnessing a spectacular explosion that could dramatically alter the night sky? The mystery of Betelgeuse remains a source of fascination for the scientific community. Much like living organisms, stars go through birth, life, and death in ways that often challenge our understanding. Betelgeuse, a red supergiant, resides on the outer edge of our galaxy and has been the subject of intense study due to its colossal size and advanced age. Its reddish hue and variable brightness have caught the attention of both amateur and professional astronomers over the years. Its fluctuating luminosity and color changes have sparked curiosity, but recent events have intensified these questions regarding its future. As Betelgeuse approaches the end of its life cycle, its sheer size is remarkable. It is over 700 times larger than the Sun, so massive in fact that if it replaced the Sun, its outer layers would extend far beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in the process. This enormous size reflects its current stage in stellar evolution. Having exhausted the hydrogen in its core, Betelgeuse is now expanding and cooling, signaling that its end is near. Betelgeuse is estimated to be around 8 to 8.5 million years old, which may seem young by human standards but is ancient in terms of stellar lifespans. Over millions of years, this star has undergone dramatic transformations, evolving from a hot blue star to the cooler red supergiant we see today. These changes are driven by the balance between nuclear fusion and gravitational forces, which cause stars to expand and contract throughout their lives. The red hue of Betelgeuse results from its lower surface temperature compared to hotter stars like the Sun. While the Sun's surface temperature is around 5,500 Kelvin, Betelgeuse's is much cooler, around 3,500 Kelvin. This cooler temperature causes it to emit light at longer wavelengths, giving it its characteristic red appearance. However, this color change is more than just an aesthetic feature. It provides astronomers with valuable insights into the star's internal processes and ongoing evolution. The color and brightness of Betelgeuse have not remained constant over time. Ancient civilizations, including the Romans and Chinese, once described Betelgeuse as yellow, and it wasn't until the 9th century that Arabic astronomers noted its shift to red. This color shift marks the star's natural progression from a hotter, younger state to the cooler red giant we observe today. In addition to its changing color, Betelgeuse is classified as a variable star, meaning its brightness fluctuates over time. These variations can occur in both short-term cycles lasting days and longer-term patterns spanning years. The irregularity in Betelgeuse's luminosity adds to its mystery. Unlike other stars that exhibit predictable brightness patterns, Betelgeuse sometimes deviates from these trends, suggesting that complex, not yet fully understood processes may be occurring within it. One of the most notable events in recent history was the Great Dimming of Betelgeuse in 2019. This extraordinary phenomenon sent shockwaves through the scientific community, as Betelgeuse, typically one of the brightest objects in the night sky, lost a significant portion of its brightness. The star's luminosity decreased at a rate of 0.01 magnitudes per day, reaching its dimmest point in February 2020. This drastic change raised many questions about what was happening to the star. One of the challenges in studying Betelgeuse lies in the delay between an event and its observation on Earth. Light from Betelgeuse takes over 725 years to reach our planet, meaning that when we observe the star, we are essentially looking at how it appeared in the past, not in real time. This delay makes it difficult to track rapid changes in the star's behavior, complicating efforts to predict or explain its fluctuations. In response to these unusual observations, astronomers, including Andrea Dupree from the Harvard Center for Astrophysics, have been closely monitoring Betelgeuse using advanced instruments like the Hubble Space Telescope. These observations have provided crucial insights into the changes occurring in the star's outer layers. Data from Hubble revealed that material was being ejected from Betelgeuse at speeds of up to 200,000 miles per hour, forming a dust cloud that partially obscured the star's surface and contributed to its dimming. This rapid mass loss has led some scientists to speculate that Betelgeuse may be approaching a much more dramatic event, a supernova. The big question remains: is Betelgeuse on the verge of exploding in a supernova? A supernova marks the violent death of a massive star, and if Betelgeuse were to reach this stage, its explosion would produce an incredibly bright burst of light, visible even during the day. This event would outshine the full moon and offer a rare opportunity to study the final moments of a massive star's life. However, despite the spectacular nature of such an explosion, Betelgeuse's distance from Earth, about 725 light-years, ensures that no direct harm would result from the event. Several theories have been proposed to explain Betelgeuse's recent dimming. One hypothesis suggests that it marks the beginning of the star's transition to a supernova. Another possibility is that a dust storm, created by the star's ongoing material loss, is blocking its light. Some experts believe that the dimming could be due to changes in Betelgeuse's outer layer or photosphere, possibly caused by the formation of a massive dark spot on its surface. Regardless of the cause, Betelgeuse's dimming remains a fascinating and active area of research, offering valuable insights into the life cycle of massive stars and the dramatic transformations they undergo. While the potential for a catastrophic Pluto-Neptune collision continues to fascinate astrophysicists, it is crucial to delve deeper into the complex mechanisms that govern their orbits. A huge area of concentration for cosmologists, red supergiants like Betelgeuse are crucial to our understanding of stellar evolution. These stars represent the final phase of a massive star's life before it explodes in a supernova. Their tremendous size and relatively short lifespans make them ideal subjects for studying the processes that lead to a star's death. Moreover, the energy released by these stars during their final stages contributes to the formation of heavy elements, which are essential for creating planets and life as we know it. If Betelgeuse were to explode, it would provide a rare opportunity to observe a supernova up close. Supernovae play a key role in enriching the interstellar medium with heavy elements, which are then incorporated into new stars, planets, and potentially life. The possible supernova of Betelgeuse could have significant implications for our understanding of these cosmic events, and would provide a spectacular sight for astronomers and stargazers around the world. While Betelgeuse's great distance from Earth ensures our safety from any harmful effects, the study of its dimming and potential demise will continue to offer valuable insights into the larger processes that govern stellar evolution. Red supergiants like Betelgeuse offer crucial clues about the universe's development, and their explosive deaths play a critical role in shaping the future of galaxies and star systems. As astronomers continue to observe Betelgeuse's changes, the data gathered from this famous star will likely offer new perspectives on the broader field of stellar evolution. The study of red supergiants and their eventual fate provides essential information about how massive stars live and die. By understanding the mechanisms driving these processes, scientists can make more accurate predictions about the life cycles of other stars in similar evolutionary stages. Betelgeuse's behavior may also help uncover the mysterious factors influencing variability in stars. Astronomers are likely to use Betelgeuse as a benchmark for comparison, studying its fluctuations alongside those of other stars to refine models of stellar behavior. The mass loss observed in Betelgeuse offers a glimpse into the extreme conditions experienced by red supergiants. As the star approaches the end of its life, its outer layers will likely become even more unstable, shedding significant amounts of material. Understanding this mass loss is vital for predicting how other red supergiants will evolve. Supernovae are not only dazzling cosmic events but also fundamental to the distribution of heavy elements throughout the universe. When a massive star like Betelgeuse explodes, it releases elements such as iron, carbon, and oxygen, building blocks for new planets, stars, and possibly life itself. If Betelgeuse were to undergo a supernova explosion, it would contribute to this cosmic cycle, enriching the interstellar medium and paving the way for new star systems. The shock waves from a supernova can compress nearby gas clouds, triggering the formation of new stars. The radiation released during the explosion can influence the chemical composition of these new stars and planets. Understanding these processes is crucial for comprehending the future of the universe. As Betelgeuse continues to evolve and exhibit unusual behavior, astronomers will intensify their efforts to study it using advanced tools like the Hubble Space Telescope and various observatories. These continuous observations will provide essential data that will improve our models of stellar evolution, particularly in the areas of mass loss, brightness variability, and other phenomena that characterize the life cycles of massive stars. In conclusion, the study of Betelgeuse offers a priceless opportunity to learn about the life and death of stars, particularly those much larger than our Sun. While our Sun is a medium-sized star with a long life expectancy, understanding the behavior of red supergiants like Betelgeuse allows us to make more precise predictions about the fate of other massive stars. Furthermore, the insights gained from studying Betelgeuse can deepen our understanding of cosmic forces such as galaxy formation, star clusters, and planetary systems. As we continue to monitor Betelgeuse and other red supergiants, we will gain a better grasp of the key processes that govern the universe, helping us answer some of the most fundamental questions in cosmology. Beyond the excitement surrounding Betelgeuse's potential for a supernova explosion, this star offers a rare glimpse into the final stages of stellar evolution. Its enormous size, unpredictable behavior, and impending demise provide valuable insights into how stars evolve and ultimately perish. The study of Betelgeuse not only helps us understand the complexities of this particular star but also sheds light on the life cycles of other massive stars and their impact on the universe as a whole. As scientists observe Betelgeuse's development, they continue to view it as a natural laboratory for studying stellar death. Understanding its transformation into a supernova, should that occur, will help us grasp how other stars of similar size and composition follow the same path. Supernovae are crucial events in the life cycle of a star and serve as significant moments in the ongoing evolution of the universe. Betelgeuse's behavior, particularly its recent dimming and fluctuating brightness, provides astronomers with a valuable opportunity to refine their models of how red supergiants behave as they approach the end of their lives. While the exact cause of its recent dimming remains unclear, one thing is certain: Betelgeuse is a key piece of the puzzle in understanding stellar death and the cosmic processes that govern it. The significant mass loss observed in Betelgeuse is another fascinating aspect of its final years. As the star sheds material at such a rapid pace, scientists can learn more about the future and potential fate of similar stars. This mass loss not only signals Betelgeuse's imminent end, but also contributes to our understanding of how red supergiants influence their surroundings. The material ejected by the star will eventually mix into the interstellar medium, affecting the formation of new stars, planets, and other cosmic bodies. Astronomers, using both ground-based telescopes and space-based observatories, are continuously gathering new data on Betelgeuse. Observations from instruments like the Hubble Space Telescope allow them to gain a deeper understanding of the star's behavior and internal changes, helping to track how stars like Betelgeuse interact with their environments, particularly in their final stages of life. These studies also offer new insights into how rapid mass loss and variable brightness in such stars shape the overall structure of our galaxy. The mass loss from Betelgeuse is particularly intriguing, as red supergiants like this eject enormous amounts of material into space, significantly impacting the surrounding interstellar medium. This process enriches the medium with heavy elements, which are crucial for the formation of future stars and planetary systems. When these elements are released into space, they become the building blocks for new stars, planets, and possibly even life itself. As Betelgeuse continues its journey through the later stages of its stellar evolution, astronomers remain keenly aware that its potential supernova could trigger the birth of new stars. The explosion would release vast amounts of energy, compressing nearby gas clouds and fostering the formation of new celestial bodies. This is one of the primary ways in which the universe renews itself, creating the raw materials for the next generation of stars and planets. Although the potential for a supernova is exciting, it is unlikely to pose any direct threat to Earth. The vast distance between Betelgeuse and our planet, approximately 725 light-years, ensures that any harmful radiation or shock waves would not reach us. However, the observational data gathered during this process will continue to provide invaluable information on how stars evolve, die, and contribute to the life cycle of the universe. These findings will help us understand what future stellar events could mean for other star systems within our galaxy. Betelgeuse's approaching demise, whether through a supernova or another event, will be studied in great detail, not only for the wealth of information it provides but also because it represents broader principles of stellar evolution. The star's behavior as it nears its end can teach scientists more about how stars of all sizes age and ultimately perish, allowing them to refine their models of stellar life cycles and the processes that occur when a star runs out of fuel.